be graphing. Hey guys, today we're going to be graphing in standard form, and we're going to start by reviewing vertex form. Okay, that's why the notes for today are called vertex in standard form of a quadratic. So if you remember, this is the parent function right here, y equals x squared, where when you graph this one, the origin is at 0, 0. Excuse me, the vertex is at the origin at 0, 0. Okay. The axis of symmetry is the line that cuts this parabola in half. Okay, it goes right through the 0 on the x-axis. That's why it's x equals 0. Okay, and then if you want to be more specific, you can actually make your little table, and this is x, and this would be y equals x squared. So if I plug in a 0, we get 0. If I plug in a 1, actually this way, 1. 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on, right? Same thing over here, negative 1 squared, or negative 1 times negative 1 will give me a positive 1. Negative 2 squared will give me a positive 4. Negative 3 squared would give me a 9, and so on. So if you plot those points, that would be 1, 1 on this side, and negative 1, 1, 1, right? Because there's a symmetry. So they'll look exactly the same from on the right side as the left side of the axis of symmetry. So 2, 4 is here. So you go to the right 2, up 4, and then 3, 9, negative 3, 9. Okay. All right. So this is what our vertex form looks like. Whatever number is inside the parentheses, that's going to be the x value of the vertex. Whatever is being added or subtracted on the outside of the parentheses, that's going to be the y value of the vertex. And then the a in the front is going to tell you if it's going to be opening up, down, and if it's going to be wide or narrow. Okay, so that's a review on vertex form. And then let's do example 1. So here's example 1 here, where our vertex, and I'll leave it here. Our vertex, remember, it comes from, the x value comes from inside. Sorry, let me color coordinate. The x value comes from inside the parentheses. And now careful though, because it's always the opposite sign. So if this is +1, then our vertex is going to be -1, our x value. And then we have a -4 outside of the parentheses. That's our k. And that one is exactly what the k is. If k is -4, then that's -4. So just watch out for the x value of the vertex, okay? They're always opposite signs. Okay. All right, and then our axis of symmetry is just whatever the x value is for the vertex. The vertex here is -1, the x value of the vertex. So then it's -1. And then if I want to graph it, the vertex here, we said it's -1, 4, -4, so it would be down here. Okay. And then we know that it would go up 1 to the right and over to the right. I'm just guiding myself with the parent function, right? It goes here 1 over and 1 up, and then now it's going to go 2 over and 4 up, and so on both sides. So that's what I'm going to do. So 2 over and 4 up, 1, 2, 3, 1, 2, 3, 4 would be here. So symmetry on the opposite side. And then 1, 2, 3 over and 1, 2, 3, 4, 5, 6, 7, 8, 9 up. And then symmetry on this side. Oops, it should be here, my bad. Okay, so there is our parabola. Okay. Because there's nothing in front of the parentheses, so it's just going to be the same values, except that we had that -4, so it shifted down, and then +1 inside the parentheses moves it to the left. Now remember, we did that also when we did vertex form, how the h inside is going to move it left or right. Okay, so this one, second example. So the vertex, again, comes from inside the x value of the vertex, which is also going to be our axis of symmetry. So it's going to be the opposite value. So that's a -1. So then our x value for the vertex is going to be a +1. And same thing for our axis of symmetry. Oh, over here, sorry guys, I forgot to write the axis of symmetry here. X equals -1. So the symmetry is right there. All right. And then here our k is 4. So then 4 is the y value. And it's always the exact same for the y value. You don't change it like the x value. All right. This is a new part that we haven't done before. See how standard form is different from vertex form. So standard form, we haven't graphed standard form before. We've factored with it, okay? And we've used the quadratic formula, and we always can. Today we're gonna find the vertex. So we're going to look at the coefficients a and b. So if you don't remember, a, it's what's in front of the x squared, and b is what's with the x. Okay, as long as all three numbers are on the same side, or all three terms, then I can get my a and my b. When we have this a or b, we can actually find the x value of the vertex. So this is the main equation you're going to use. I don't like the y value here. It's just not, you cannot tell exactly what it means, but I'll tell you what it means. So this is the same equation, right? Because the x value of the vertex and the x-axis are always the same number. So when we're looking for it, we're going to be using this equation. So again, the equation is -b/2a. So -b divided by 2a. And then we look at our example here. Our example is x squared plus 2x minus 3, where there's nothing in front of the x squared, so there's a 1. That means the a is a 1. We change colors here. So that's going to be our a. I'm just going to put here a equals 1. And then our b is going to be whatever's with the x, and b equals 2. So then here, this equation is going to be -2 because b is 2, divided by 2 times a, and a, we substitute in the value, and a is 1. So pretty much this is 2 divided by 2, -2 divided by 2, because 2 times 2, 1 is 2. So -2 divided by 2 is 1. Now this is our axis of symmetry, okay? Now we still haven't found our vertex. So how do we find our vertex? So to find our vertex, we're going to do this right here. Vertex. Since this is not in vertex form, what we have to do is we have to get this x value that we just found, and we're going to substitute it into this equation, or the quadratic equation they give us. So it is x squared plus 2x minus 3. So we're going to substitute in place of x. So I'm going to put parentheses wherever there's an x. And we're going to substitute that -1. So we're going to substitute -1, -1. And then we're going to do the math. So here, y equals -1 squared is going to be +1, plus 2 times -1 is going to be -2 minus 3. And then you just put them together, and y equals 1 plus -2 is -1, minus 3 is -4. So that's going to give me the y value for our vertex. So here our x value was -1, and then our y value is going to be -4. So if I wanted to graph this, we're going to go -1, -4. Okay, and I just realized it is the same problem that we had on the other one. So -1, -4 goes here, then up 1 over 1, over 2, up 4. So that would be here. And then over 3. And I'm always starting from the vertex here. So to the right 3 and up 9. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9 would be here. And actually it turns out to be the same graph that we had before. Now, why does it look so different? Well, because in example 1 over here, it was in vertex form, so we couldn't tell. Well, why does it look different, but it's the same graph? Well, if I wanted to look the same, we would actually have to work it out. So this is squared here. So that means I would write this twice. Then you have a -4. Then I would do FOIL, and that would be x squared minus x, or 1x, and not minus, plus, wow. 1 times x would be another 1x, and then 1 times 1 is 1. Bring down that -4, combine like terms, so x squared, these will combine to give me 2x, and then 4 minus 1 is -3. So we go back to example 1 over here. That's exactly what we started with here. Okay. So now you can tell how you get from one to the other. All right, so next one, let's do it again. So first thing we want to do is find the x value of the vertex, or the axis of symmetry, which is -b divided by 2a. So our a here, there's nothing in front of the x squared, so that's our a. So a is 1. So then b here is whatever's next to the x, and that's going to be -2. Okay. And then we're going to substitute it into this equation. -b to a, and b is -2, and a is 1, right? A is 1. So we do a little math. We have a negative of a -2, which will be a +2, and 2 times 1 is 2, and then 2 divided by 2 is 1. So our x value of our vertex is going to be 1. Then we are going to find the y value by substituting the x value we just found by using that vertex, the formula for vertex, which is this one. So we're going to plug in, actually that's the formula for, well, it's for the vertex, the x value of the vertex. So we're going to substitute in the 1 in place of x, so 1 and 1. And then y equals 1 squared is 1. 2 times 1 is 2. And bring down that -5. And together, that's going to give me 1 minus 2 minus 5. So 1 minus 2 is -1. Minus 5 would be -6. And if you get stuck, you can always use the calculator, right, to calculate that. So let's do another example. I don't like how crowded these are. Let me make more space here. Okay, so here, for first thing you want to do is find your A. So A is 1. Your B is -6. Okay, so A comes from here. B comes from here. And we use our equation x equals -b over 2a. So we plug in negative b, which is a -6. Watch out when you have a negative. And then a is 1. So that's going to give me +6, which I really don't need to put the positive, divided by 2. So my x here is 3. Then I find my y value by plugging into the quadratic equation we started with, that 3, wherever there's an x. So x squared minus 6x plus 5, substitute in that 3, y equals 9 minus 18 plus 5. And you can just get a calculator, plug them all in. 9 minus 18 is negative 9, plus 5 would be negative 4. So that's for y value. So then x is 3 and y is 4, negative 4. And if you are not sure, guys, you can always check yourself with the graphing calculator. Example 4. I don't know why we have so many examples. Ya se me hacen muchas. All right, let's do example 4. We're going to find the x value. So a is 2, b is 4. So then we're going to do x equals negative b divided by 2a. So that's going to be negative b over 2a. B is 4. A is 2. So that's going to be negative 4 over 4. Negative 4 divided by 4 is negative 1. So there's our x value. So that's going to go here. And then we find our y value. So our equation is 2x squared plus 4x plus 1, right? This one. Then wherever there's an x, we're going to put parentheses because that's what we're going to substitute. Don't forget that that first x is squared. So make sure you put the squared outside the parentheses. Then we sub in that negative 1, negative 1. And we end up getting negative 1 squared is 1. So that's going to be just 2 times 1 is 2. And that's going to give me a negative 4 and then plus 1. Altogether, 2 minus 4 is negative 2 plus 1 is negative 1. So they're both negative 1. Okay, so if we graph it, it would be to the left 1 and down 1 to start with. Okay, and then I'm not asking you to graph, so all we're doing really is finding the vertex, and then just remember that the axis of symmetry is the same value as the x value on your vertex. Right, so again, our a here is the first number. That's with the x squared. So it's 3. The b is 12. So now we're going to do x equals negative b times 2a, because that's the equation to find the x value of the vertex. So negative b, so negative parentheses, 2a, so 2 parentheses. Then we sub in the a, which is 3, the b, which is 12. And then we simplify, so that's going to be negative 3, and then 2 times 12 is 24. All right, so this one's going to be a fraction, apparently. Oh my gosh, sorry. It's not going to be because I put it in the wrong spot. So b is 12, that's going to go here, and a is 3, so that's going to go there. So that's going to be negative 12, and 2 times 3 is 6, so it's going to be negative 2. So that's our x value of the vertex, also our axis of symmetry. And then y is 3x squared plus 12x plus, 12x plus 3. And then we're going to substitute in place of x, that negative 2. So negative 2 from over here. So the math, that's going to be 3 times 4. Negative 2 squared is 4. And then 12 times negative 2 would be negative 24 plus 3. 3 times 4 is 12. That's going to be negative 24. So altogether, 12 minus 24 is negative 12, plus 3 would be negative 9. So that's the y value of our vertex. You can always check yourself with the graphing calculator. Decimals Online Graphing Calculator. All right, almost done. Last example, a here. There's nothing in front of the x squared, so it's a 1, but there is a negative, so it's a negative 1. B is 6. So then we do x equals negative b over 2a. So negative parentheses times 2 parentheses. Now don't do the mistake that I did in the previous one. A is down here, right? That's negative 1, and b is up here. That's 6. So we have negative 6 over negative 2, which is going to give me a positive 3. That's going to be the x value. That's going to go here. Then we plug it into the equation we started with here. Negative x squared plus 6x minus 15. So that's going to be negative parentheses squared plus 6 parentheses minus 15. So that's going to be, we're going to substitute in that 3, right? And then we're going to simplify that. That negative, though, is outside. So we first square the 3, which gives me a 9. And then you bring down that negative. So it's going to be negative 9. Plus 3 times 6 is 18. And then bring down that minus 15. And then combine like terms. Negative 9 plus 18 is positive 9 minus 15. Wow, I don't know why I can't think right now, but that would be negative 6. Yes. Okay. So then negative 6 goes here. So if I was going to graph this, we would go 1, 2, 3 to the right, 1, 2, 3, 4, 5, 6 to the left, and this would be opening down. Why? Because we have a negative at the beginning. All right, guys. Your assignment has been posted. Go ahead and get started.